Okay, I hope I'm not going too fast here. The naming actually gets a little bit faster because it's repetitive. All you have to do is learn the new functional groups. So definitely important are the carboxylic acids because you'll see them in chem, but you'll also see them in a lot of the bio course. This is the old name for the acids. Technically, they should be called alkanoic acids, but I'm old enough that I probably would call it carboxylic acid by accident. So the general formula for a carboxylic acid is this. Okay, so you have some undetermined number of hydrogen or carbons coming off of there, but what you're looking for always is that double bond OH group at the end. And let's just go through really quickly how to name these ones. If I have one, okay, and again, make sure you're counting your hydrogens carefully. The carbon can only have 4 around it, so 1, 2, 3, 4. This would be 1 carbon meth, and then it would be anoic acid. That's where you get the name alkanoic, because this is the alkane part, and there's the anoic acid part of it. The one that you'll probably deal with most often in chemistry, biology, and life would be ethanoic acid, which is also called acetic acid, which is also called vinegar. Okay, this is the correct IUPAC name for it. This is what it is traditionally called in chemistry labs, and that's what it is traditionally called in salad dressings. The nice thing about the acids is that the part that has the carboxylic group on it always gets priority. So if I said to you, okay, how would you name this mess? Let's stick a chloro, let's stick a methyl group on there. And for fun, let's stick, I don't know. There we go. There we go. So how would you name this? You'd be like, oh, okay. First things first, I look at this functional group. I'm like, oh, it is an acid. How many carbons are in the parent chain? Well, this is a parent chain of my acid. So I'm going to call that a butanoic acid. So it's a butanoic acid. And what do I have on my butanoic acid? Well, this is carbon number 1, carbon 2, carbon 3, and this is carbon 4. Off carbon number 2, I have a chloro. Off carbon number 3, I have a methyl. Just to mix it up, off carbon number 4, this part is an F because it's 2 carbons, but there's that O there, so I have an F-oxy group on 4. So that's a mess. Let's see what we would name it. Now I'm just going to go alphabetically like we did before. So C goes first, so it's going to be a 2-chloro, 4-F-oxy, 3-methyl butanoic acid. Okay, and really, that's as in-depth as it's going to get. There's no other way to name that. The only thing that you might run into is a dioic acid. So let's do this one. Good time to point out, it is always the oxygen that is attached to the carbon. It would be wrong to draw this. Okay, and you'd actually get a mark taken off. You can't actually get the Lewis octet when you start trying to draw the 8 electrons around everything. It doesn't work that way. So you'll notice that whenever I write, I usually write my carboxylic acids on the right because it's just so much easier for me to think COH. If I write them on the left, you'll notice I will write the C and then I'll write backwards OH because in my head, I have to always remember to attach the O to the carbon. So what would you call this? Well, my base chain or my parent chain is 3, so it's propane, but it's propane dioic acid. Lots of vowels there. How many oic acids do you have? You've got 2, so it's a dioic acid. So propane dioic acid. Okay, that's it for carboxylic acids. You'll get lots of practice on the worksheets. Next thing I want to move on to is esters. Esters are exciting because esters are the things that they use in artificial flavorings and artificial smells. So if you have a bottle of vanilla extract that it is made artificially, it'll have esters in it. Likewise, if you have those like perfumes and smelly things that smell like strawberries and fruit, It's all based with esters. We used to do labs with them, or I used to do labs with them, and they were great because some of them smelled really great, some of them smelled really bad, but massive headaches afterwards. And then they decided afterwards it probably wasn't worth whatever it was inhaling to get the headaches. It wasn't worth making it. So the ester is, it's a good one. So I'm not even gonna give you the general formula. I'm just gonna give you one and explain how I name it. So I am a creature of habit. I always write my esters with this format. For an ester, you're looking at a C double bond O, not an OH, right? Because remember, the carboxylic acid looks like this. Think of an ester like a carboxylic acid, but instead you've taken the H off and you've put another bunch of C's on there. So this is what makes your ester functional group. And then how you name it is, if you line it up like this, you say, well, this is what's coming off that single bonded O. That's a methyl group. And this is, don't forget to count this one. A lot of times it's really easy because you're focused on this to go 1, 2 carbons, but it's not. It's 1, 2, 3 carbons. So this is a prop. So the way that you name it is, it's like, this is the that's like your parent chain. Your parent chain is the thing that's coming off that C double bond O. So this gets named first. This would be called, methyl propanoate. So this one's a little bit tricky because you know how an aldehyde ends with al, and a ketone ends with one, and a carboxylic ends with oxalic acid. This one has nothing to do with the name. So this is methyl propanoate. So the methyl group comes first, that comes second, and it's propanoate. If I showed you the stick figure diagram for this, so 1, 2, 3 would be double bond O, O, right? Remember that represents a carbon. So this is a methyl group, 1, 2, 3, that's methyl propanoate. If I took this and I just stuck another carbon on it, this would then become ethyl propanoate because I now have 2 carbons. So ethyl, what's it on? A 1, 2, 3 propanoate. So that would be called ethyl propanoate. I think we could get into more, well, let's do this one. There's so much more we could do, but kind of hard because I'm not there, but okay. So if we name this one, you'd say, okay, fine. I'm looking for the ester functional group. So there it is right there. This is an ethyl group. This is a 1, 2, 3, 4. So this would be ethyl butanoate. Now, if I want to be super tricky, let me stick a BR here. So the bromine has nothing to do with the ethyl group. The bromine comes off here. So all you do is you just insert it. It's still an ethyl. On my butanoate, on the 3rd carbon, you'd say ethyl-3 bromo-butanoate. You're just telling me that, and I'll write it out properly for you. Ethyl-3 bromo. It's like the black marker is the only one that's worth using. It's telling me on the bute part of my butanoate, on the 4 part, what is there on the 3rd carbon? There's a 3 bromo. So that is it for esters. I'm going to stop there.